Did you know that meat is considered a food product with the greatest environmental risk? Did you know that wastewater from slaughtering animals can cause eutrophication if the water is discharged and not treated properly? Did you know that marine protists can help solve this environmental crisis? Well, just in case you answered no to any of these questions, let's just have a brief lesson on how wastewater from slaughtering animals can be treated with the help of marine protists. But before we begin, I just wanted to let you know that these are my chickens and they were not harmed in the making of this film. According to Latifi et al. 2020, wastewater is defined as water that has been contaminated with pollutants and microbes with relation to the discharge of untreated or partially treated wastewater. The production of meat is associated with large quantities of meat processing wastewater, and as I just described, this wastewater has high concentrations of nutrients. Now, when a body of water accumulates high concentrations of nutrients, it's likely that eutrophication will occur, as shown in this image here. Now, although it's not impossible, it's extremely difficult to recover a body of water once eutrophication has begun, due to the extreme deterioration of water quality and likely desiccation of all living organisms. So rather than cleaning up the mess, I will be discussing the cutting-edge research that looks to remediate wastewater before eutrophication happens. In recent years, research has been growing in hopes of finding a marine protist to solve this slaughterhouse wastewater problem. The image here shows the marine protist that was examined in the 2018 study. The researchers hypothesized that this marine protist would do a great job bioremediating the wastewater because there is an excessive amount of nutrients in the wastewater that marine protists actually love. The researchers found that the slaughterhouse wastewater is extremely beneficial to their growth and biomass production, as shown in the graph here. The results indicate that as time and days increase, the biomass of the marine protist also increased. Therefore, Hip et al. Concluded that the slaughterhouse wastewater contains nutrients and trace metals that benefit the marine protists. I also wanted to highlight that COD, or the chemical oxygen demand in the wastewater, goes down as biomass goes up. This marine protist was studied by Latifi et al. In 2020. The objective of this study, similar to the other studies, was to analyze the ability of phycoremediation technology in treating meat processing wastewater. This marine protist is a type of green algae and has a good potential in removing nutrients such as nitrogen, phosphorus, and lipid accumulation. It also has the ability to survive in adverse and robust conditions of pH, temperature, light, and salinity, making it an excellent candidate to survive the conditions of slaughterhouse wastewater. This diagram is from another study by Bermudez et al. 2017. This paper examined the utilization of nutrients in wastewater to then harvest the microalgae for feedstock to create biofuels. According to Bermudez et al. 2017, using wastewater as a source of nitrogen and phosphorus represents an attractive option to cultivate microalgae simultaneous with contaminant removal. The utilization of marine protists for bioremediation of wastewater from the process of slaughtering animals appears to be the best answer to all the questions we've ever asked. This process is eco-friendly, it's cost-effective, it only requires adequate sunlight and a constant supply of nutrients. Growing algae in wastewater has more advantages than traditional algae farms because this time you're replacing chemicals with wastewater, which may reduce the cost of production, and most importantly, it's amazing for the environment. The smell from the farms is so nauseating that it has reportedly caused chronic illnesses in the families that neighbor the farms. Elsie Herring is pictured here at her home in North Carolina and is in the process of suing a hog farm. My hope is that this new process of bioremediation be used to treat slaughterhouse wastewater globally so that not one more family is impacted by this huge environmental issue. To conclude, according to recent studies, marine protists have come to the rescue to naturally treat highly contaminated water that is rich in nutrients. This option for bioremediation has many positive impacts, such as keeping bodies of water free from excess nutrients and greatly limiting the chances of eutrophication, and most importantly, keeping neighboring families healthy.